Hey guys, hope you're doing well. Today we're going to talk about one of the most important formulas that you're going to learn in geometry, and it's actually really going to help you with a lot of classes. It's going to help you with the SAT, the ACT, algebra, and then even beyond that into pre-calculus and calculus. So this is a really important formula, and that is the distance formula. So there's a lot of, what it does is it obviously just calculates the distance. So if you have 2 points, you can have the 2 points on a graph. You can have the 2 points just their coordinates. It'll tell you the length of a segment that would connect the 2 points. And there's a lot of methods and different ways that you could calculate this distance. The first one's obviously the easiest, and that's just counting. If a segment is vertical or horizontal, you could simply count the units to connect them. So if we had like a number line, and we had 3 and 12, you could just count all the ticks on the number line, and you would end up with 9. That's really easy, and if we can do that, we want to do that. But the thing is, when we have more complex questions, we're not going to be able to do that. So the other method, that one of my favorite methods, is actually to use right triangles. So that would be when you use the Pythagorean theorem to help you out. So you would create a right triangle from the 2 points that you get, and then you would use the Pythagorean theorem to find the hypotenuse, which would be the distance between the 2 points. And we'll go through an example explaining what the heck that means. I know that can sound confusing, but that's a cool way to do it. But now the most important and most practical one is the formula. And this is just the way that you want to do it basically every time, because you can do it without fail. You know it's right, and it's fairly quick to use. And this one's worth memorizing. So I'm going to write that here, memorize. So this is the one that you can use no matter what. If you're given 2 points, if you're given 2 points on a graph, if you're given coordinates, you can always use this. And it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And it's not too hard to memorize. I'm sure you can do it pretty quickly. And you may notice that the distance formula is directly related to the Pythagorean theorem. It's just easier because you don't have to draw a right triangle. The distance formula is easier. So the distance formula really is using the right triangle method, but it's just doing it in a little bit easier way. So we'll show you what that means in a second. So let's do some practice here. So we're going to start with using the right triangle method. I know I just said that the distance formula is the quickest way, but I just want you to see what I mean when I say the right triangle method. So we're going to use that to find the length of the segment AB, where A is 1, 4. 1, 4, we'll put that right here. And B is 6, 5. So 6 and then 5. So A is 1, 4. B is 6, 5. And I'm going to create my right triangle. So 1, let me write this as A. Let me write this as B. So if I just connected this point to I just connected A's x coordinate to B's x coordinate. Well, that's going to be 5 units away, right? Because this A's is at 1, B's is at 6. So this is a 5 unit segment. And then now B is, now I'm connecting the Y's. So I started at A's coordinate, which is 4, and I went to B's, which is 5. So I went up 1. And now I want to know the distance between A and B. Well, the fastest way, or the quickest, the shortest way to get from any point to another is the diagonal. So that would be the distance. So this is what we're looking for. That's the distance. Well, if you notice, we just created a right triangle. We can use the Pythagorean theorem. So we get a squared plus b squared equals c squared. We know that that's the Pythagorean theorem. And we know that C is always the hypotenuse, and that A and B are the side lengths. Well, one side length is going to be 5, so we'll get 5 squared. Another side length is going to be 1, so we'll get 1 squared, equals C squared, that hypotenuse that we need to find. Well, 5 squared is 25, 1 squared is 1. C equals the square root of 26. That is the distance between the points. So distance equals square root of 26. So that is one way to find the distance. You can always just graph them, then create a right triangle. It's quick, it's easy, and it's reliable. You know it's going to work. Now let's do it with the distance formula, and you're going to notice that you get the same answer. So the distance formula, so I'll just say df equals, that's when we have the square root of x2 plus x1, or minus x1, quantity squared, plus y2 minus y1, quantity squared, square root of the whole thing. Well, x2 minus x1, I'm going to plug in my x2 and my x1. I'm going to make x2 be the 6 from the B point, so 6 minus 1 squared plus y2 is 5 minus 4 quantity squared. I'll get, all right, so 6 minus 1 squared, that's 5 squared, that's going to be 25 when you square it, plus 5 minus 4 is 1, squared is 1, and I get, well, square root of 26. So the distance formula gives us the exact same answer, and that's not on accident. They always should give you the same answer. And if you notice, we're almost doing the exact same thing, aren't we? That we ended up doing 5 squared plus 1 squared. Well, that's exactly what we did here, isn't it? Then we ended up taking the square root because we had to square root both sides of the c. That's exactly what we're doing in the distance formula. You'll notice that the distance formula is actually derived from the Pythagorean theorem. The Pythagorean theorem is the reason it works. So it's really interesting to do that. And if you ever want to do either method, you can. So both are options. But the distance formula is a little bit more practical, so it's better to just memorize it because sometimes you won't really be able to draw a triangle and things like that. So memorize the distance formula, but I just wanted to show you guys, well, where does this come from? It comes from the Pythagorean theorem. So now it just says point C is at 2, -8, point D is at -3, 4. Determine the length of segment CD. So now I just want to use my distance formula and plug and chug. So this is what's great about it, is now for this I don't have to draw a triangle. All I need to do is use the formula, which says x2 minus x1 squared plus y2 minus y1 squared. Just got to memorize this. Well, x2 is going to be that D point, so -3 minus 2 quantity squared plus, then we get the y2 will have 4 minus -8 quantity squared. So, well, now we're going to clean this up a little bit. It's a little dirty right here. So -3 minus 2, well, that's going to be -5 squared plus, all right, so now we got to be careful, 4 minus -8. Well, that becomes 4 plus 8, so we get 12 squared. And now I'm going to just square everything. -5 squared, well, anything negative when it's multiplied by itself becomes positive. So I'll get a positive 25 there, plus 12 squared is 144. Then 144 plus 25 actually gives me 169. And the square root of 169 is 13. So the distance between, distance of segment CD, the length of segment CD, I'll just say distance slash length of CD is 13 units. So we can do something pretty complicated really quick with the distance formula. Let me label my units just so everyone knows. So it's really interesting and it's really cool how well this works, and really the key is just to memorize the formula. That's really the only thing that you can do, and it really will make a difference on your SATs, the ACT, and just all the classes you take. It's a really great thing to have. So thanks for watching. Let me know if you have any questions.